morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to talk about dividing monomials. We're going to talk about the quotient rule and the integer exponents rule. The quotient rule for exponents states that a to the m power divided by a to the n power is a to the m over a to the m minus n. Basically what happens here is when you divide the same base, you keep the base and subtract the exponents. If I have a over b raised to the n power, that means I'm going to distribute this n to all of the exponents inside of the parentheses, and I have a to the n over b to the n. Okay? So when I divide the same base, I keep the base and I subtract the exponents. There's a little bit of an easier way to that, and I'm going to show you now in a second. Next thing, the negative rule or the integer exponents rule. When I have a negative exponents, my friends, if it's in the numerator like this first one is, I literally bring it down to the denominator and I change the sign of the exponent. Please be careful. I'm not changing the sign of the integer or of the coefficient. I am changing the sign of the integer and of the integer only. If I have a negative exponent down here and I move it up to the top, I change the sign of the integer exponent only. Not the sign of the base, but just the sign of the exponent. Okay? If I have a fraction raised to a negative power, now this one can be confusing. So again, we will go through a lot of different examples and you choose the way that you like, you choose the method that you like the best. But what can happen here is, see I have a over b raised to the negative n power. If I want to get rid of that negative n power, all I have to do is flip the inside of the parentheses. So if I had a over b, I turn it into b over a, and I have automatically now changed the sign of the outside exponent. Do not change the sign of what's inside of the parentheses. If I have x cubed over y to the fourth raised to the negative 2 power, this will become y to the fourth over x cubed to the second power, or squared. And then now I can go ahead and simplify. Do not change the sign inside of the parentheses when I'm changing an outside negative exponent. But I'll show you a couple ways to do that. And again, you're going to have to choose one way that you like, decide on the way that you want to work with it, master that way, and go from there. Yes, sir? Correct. Basically, you're just finding the reciprocal and then change the sign of the outside exponent. And last but not least, anything to the 0 power is 1. When you have an exponent of 0, the value will equal 1. So 5 to the 0 power is 1. X to the 0 power is 1. Anything to the 0 power is 1. However, there is a little trick there. If I have negative 2 to the 0 power, what will that equal? Negative 1, guys. The 0, thank you, the 0 is only affecting the 2, not the negative 2. What if I had it like this, negative 2 to the 0 power, what would that equal? That would equal 1. Those are the 3 rules that we have to learn today, guys. Now let's just go ahead and practice. So 6 to the 8th divided by 6 to the 3rd, that's 6 to the 5th. Okay? Why? Because I went 6 to the 8 minus 3. Now, things are going to get a little bit more confusing as we go on. So I don't really like to teach it with the whole subtraction thing. What you really technically did here was 6 to the 8 minus 3, which equals 6 to the 5th power. Okay? However, what if I had it 6 to the 3rd over 6 to the 8th? This would be 6 to the 3rd minus 8, which equals 6 to the negative 5th, which equals 1 over 6 to the 5th. It's a lot of work there, though, right? I got an easier way for you. Much easier. All of that is valid. All of this works. There's nothing wrong with that. However, let's picture it. How many 6's do I have up here? How many 6's do I have down here? If I get rid of 3 from the top and 3 from the bottom, am I not left with 6 to the 5th? Isn't that a lot easier? You're subtracting, you're doing the same thing, except you're doing it quicker, more efficient, and less calculations. Less room for error. Sir. No, you don't touch the bases at all. You keep the base and you're working with the exponents, just like multiplication. If I have 6 to the 3rd times 6 to the 4th, that's 6 to the 7th. Okay. Thank you, my man. How about here? 6 to the 3rd divided by 6 to the 8th. This is the example I had just told you. You could go 6 to the 3 minus 8, which equals 6 to the negative 5, which equals 1 over 6 to the 5th. That's all good. That's all fine and dandy. Or, wait a second. There's 3 6's here. Take away 3 from down there. I'm left with 1 over 6 to the 5th, and I'm done. So cancel them out. It's a lot easier than this subtraction. Yes, sir, my brother. No, it's not factoring it out at all. No. No, it's not the same concept at all. You're subtracting. But thank you, sir. Okay. I got x to the 5th divided by x squared. Get rid of these 2. Get rid of 2 from here. I'm left with x to the 3rd. That's exactly correct. Okay. 25 over 15. What goes into 25 and 15? 5. So that goes 3 times. That goes 5. So I've got 5/3. I got 9x in the numerator. I got 6x in the denominator. What am I left with? 3x is in the numerator. Done. We don't have to worry about that subtraction. I got y over 3 squared. That means that this 2 gets distributed to the exponents of everything inside the parentheses. So I've got y squared over 3 squared, which is 9. F, negative 2 squared is 4. Y squared raised to the 2nd power is y to the 4th. Z cubed raised to the 2nd power is z to the 6th, because I multiply the exponents. Remember, when I raise a power to a power, I multiply the exponents and keep the base. And x to the 1st power squared is x squared. I'm done. Sir, my brother. Yes, if I had more y's and x's here, I would. But here, I have nothing left. I'm done. I cannot simplify any further. But the answer to your question, yes. I keep simplifying until I can go no further. Thank you, my man. Does that make sense, boys? Okay. 5y to the 0, what would that equal? 5. No, not 1. Remember, only the y is being affected by 0. But now, in this bad boy here, h, everything is inside the parentheses, and everything is being raised to 0 power. So what would this equal? This would equal 1. Do you see a difference, sir? Sure, my man? May I continue, gentlemen? Thank you. Okay. 2 to the negative 3rd, what would that equal? 1 over 2/3, that's an easy one, so that would equal 1 over 8. Very good. Now, negative 2 to the negative 3rd. Does this negative get affected at all? So that's just negative 1 over 2 to the 3rd, which equals negative 1/8. You feel me? Okay. 4 to the negative 1, that becomes 1 over 4 plus 2 to the negative 3rd becomes 1 over 2 to the 3rd, which is 1 over 8. Common denominator. This 4 becomes an 8. That 1 becomes a 2. So this is 3/8. Y to the negative 5th. I got to make that a positive, so that becomes 1 over y to the 5th. Very good. I'm very proud of you. Good job, gentlemen. How about negative y to the negative 5th? No. This negative 1 does not get affected. It's being raised to an odd power, so it's still negative 1 over y to the fifth. This would be the same thing here. This would be a negative 1 over y to the fifth. Mr. Morrow, why are these both the same even though one is in parentheses and one is not? Well, and also because that's odd. When you have a negative raised to the odd power, it's going to be negative. Had that been an even exponent, then the answer would have been positive, not negative. Now, here's where we separate learning styles. And this is where you have to decide what you want to do. Choose a method, stick to it, master it, become great at it. I'm not going to tell you which way to use. You need to tell you which way makes sense to you. The easiest, well, let me not say that, that's not fair. This is the technical correct way to do it. First of all, you have a negative 1 here. Okay? And a negative 1 and you have an even power. I don't care if that even power is a positive or negative. This is going to become a positive. Anytime you have an even power and you have a negative inside the parentheses, it's going to be positive. So I distribute this guy here, technically here, and here. So this is negative 1 to the negative 2, which is 1 over negative 1 squared, which is 1. So that becomes a positive. X to the third raised to the negative 2, this becomes x to the negative 6 over 4 to the negative 2, which equals 4 squared over x to the 6th, which equals 16 over x to the 6th. That's one way to do it. Some people don't like that. Some people say it's too long. Okay, that's fine. I get it. Your choice. Some people love it. That's just pretty basic. You're just distributing that negative and then changing all the negatives to positives later. That is definitely an option. Or, I'll just do it in blue. Or, you have this x cubed over 4 negative to the negative 2. Or you could have done this. Get the reciprocal of this inside of here and change that sign. So this becomes negative 4 over x cubed. You don't change any of the signs inside of there. But you change this outside exponent. So now this becomes negative 4 squared is 16 over x to the 6th. Do you see how I have the same exact answers? Do you think I care which method you use? Actually, I do care. I want you to use the method that works for you. That's what I care about. Use the one that makes sense to you. Please don't mix and match. Do a few of them both ways. See which one you love. See which one makes sense to you every single freaking time. Which one makes sense 100% of the time. And that's what I would like you to use. Okay? This last one. First of all, again, I'm doing this on purpose. When it's negative and I have an odd exponent, the answer is going to be negative regardless. Okay? So the answer is negative regardless. I'm going to distribute this negative out. So this is 4 to the negative 3, x to the negative 12 over 3 to the negative 3. This equals 3 cubed over 4 cubed. Oh, and it's negative. And this is x to the 12th, which equals 27, negative 27 over 64 x to the 12th. That's one way, totally valid, totally awesome, totally great. Or you take the inside of here and you literally flip it and you change that sign. Literally. So you go negative 3 over 4x to the 4th. I did not change any signs in there. Why? Because I'm changing this outside sign to a positive. Now that becomes Negative 3 cubed, which is negative 27. 4 cubed, which is 64. X to the 4th cubed, which is x to the 12th. And as you can see, you have the same exact answers both times. I heard a few people go, oh, that makes me happy. That means you're learning. Does that make sense, gentlemen? Do I have one more page? Yeah. Okay. The bell's going to ring. I'm going to continue. Watch it. Homework is valid. Have a great lunch. Thank you very much and have a great day. Hope you learned a lot. I'm going to continue now. So when the bell rings, don't be too noisy, please. Okay. Here in this one. When this is the case, and you have a negatives and positives, guys, try to make all of your negative exponents positive first. And always work with numbers first. So you see you have a 27 and 18 here. 9 goes into 27 3 times. 9 goes into 18 2 times. So right off the bat, I've got negative 3 halves. Now, check it out. I got a to the negative 2. But I got to bring that up to become positive, correct? So a to the 7th times now a squared becomes a to the 9th. This b to the negative 6 comes down. So now I have b squared times b to the 6th. That becomes b to the 8th. Exactly. Exactly. Does that make sense? You can stay here, guys, if you want. Here, numbers first. 3 times negative 12 is negative 36 divided by 2. That's negative 18. The numbers are done. A to the 3rd times a to the negative 4th is a to the negative 1. B squared times b to the 5th is b cubed. I need all exponents positive, so this is negative 18 b cubed over a to the 1st power because I brought this negative 1 down.
So you can still bring it down after.
Absolutely. Once you've multiplied, if you still have a negative exponent, my man, you bring that sucker down or up. Sometimes you're left with a negative in the denominator, a negative exponent, not integer, exponent. If it's in the denominator, you bring that sucker up. Okay? With this guy, numbers first. The 2's cancel right off the bat. Negative times a negative is a positive right off the bat. 15 divided by 5, that's a 3. So we made our life a lot easier. We took all those numbers and now we know it's 3 over 1. M to the negative 2 times m is m to the negative 1. N as in Nancy to the negative 1 times n to the 0 is n to the negative 1. I cannot have these negative 1 exponents, so this equals 3 over m n positive. Why positive? Because I brought them down. And when I go from numerator to denominator or denominator to numerator, I change the sign of the exponent. Here, okay, what I like to do here before I even get involved with this negative exponent on the outside, I'm going to, very good, my brother, I'm going to simplify what's in here first. So I'm going to divide a 5 to both these guys, okay? And that'll be a 2 actually. So this will be 5 halves. I got a to the negative 2 and I got an a down here positive. I'm going to take these negative 2 and bring it down. So now I have a cubed in the denominator. I'm going to take this b to the negative 1, bring it up. So now I have b squared in the numerator. And all of that is raised to the negative 2 power. Now remember, I told you do it your way. My way, I like just flipping it and then changing the sign. It's easier. So this is going to become 2a cubed over 5b squared raised to the 2nd power, which equals 4a to the 6th, and 5 squared is 25, b to the 4th. Make sense? And then last but not least. Okay, I'm going to first clean up this first guy, make everything positive. So this is 6d over c times 3 cubed is 27. Actually, yeah, okay, yeah, that's fine. Come again? Uh, yes, it would. Let me pay attention. Learn how to do math. 6d over c squared. Thank you, son. And then here, let's clean this up. This is a d, this is a d cubed. So this is 3 cubed, which is 27. C to the negative third times 3 is c to the negative ninth. And then d to the ninth. This equals 6d over c squared times 27d squared to the ninth over c to the ninth, which then equals 6 times 27, which is 120 and 42, 162. D times d to the ninth is d to the 10th. C squared times c to the ninth is c to the 11th. And there you go. Yes, sir. To the 2d, what 2d? To the 2d. Okay, this d went bye-bye. But the 2 here, yeah, the 2 should be an 8 here. You're right. So it should be an 8. So actually I can reduce that to 81. Thank you, my man. Thank you very much. Good man. Last but not least, 3p to the 8th to the negative 1. I'm going to flip this over. That's it. Now that just becomes a positive 1. Then here I'm going to clean this up. This negative, p to the negative 2 goes down. So this becomes negative 6 over p to the 5th squared. So I have 1 over 3p to the 8th times negative 6 squared is 36 over p to the 5th squared is p to the 10th. Now 36 divided by 3 is 12. P to the 8th times p to the 10th is p to the 18th. And ding dong, the witch is gone. Yes, sir. Yes, sir. E. Yeah.
If you're dividing all of that by 2, wouldn't it then be 4c 11 at the bottom?
No, I didn't divide it by 2, my man. 162 divided by 8 is, it's not 81, it's 21. What's wrong with me today? What is wrong with me today? Thank you, sir. 162 divided by 8 is 21, not 81. Thank you, my brother. Thank you, boys, for staying. Hope you learned a lot. Have a great day. God bless you. Bye-bye.